In our previous lesson, we saw how to add and subtract fractions. In this lesson, I want us to look at a new operation on fractions, and that would be multiplication. It turns out that multiplying fractions is actually very different from adding or subtracting fractions. For one thing, we don't have to find a common denominator when we're multiplying fractions, so that part of the work doesn't even show up in this lesson. To be very honest with you, multiplying fractions is a pretty straightforward process in many cases. In a nutshell, we're just going to multiply the numerators and multiply the denominators, and our answer will be sitting right in front of us. However, if we want our answers to be in reduced terms, then we will often have to do more work than what I just described. And of course, there are questions about what to do when you multiply a fraction by a whole number or when you multiply fractions with mixed numbers. So there's really lots to do in the lesson. Now what I'd like to do is start with a basic example, just to see how the process works when you're multiplying two fractions together. Let's look at this example. Find 2/3 times 7 over 11. Now we see here a multiplication problem. I see the multiplication symbol. Some of us would call this a product, and it involves two fractions. The basic thing to do is just to multiply the numerators together and to multiply the denominators together and build a new fraction from these two products. So I look at the numerators and I see that I have 2 and a 7. I multiply those numbers together. 2 times 7 equals 14. I then look at my denominators and I see a 3 and I see an 11. 3 times 11 is 33. And so my answer is simply 14 over 33. Now, as with all the examples we'll do in this lesson, we can't stop here. We really want to know whether this answer is in lowest terms. So let's think about it just a bit. What are the factors of 14? Well, of course, there's 1, which you don't have to worry about in this case because dividing a 1 out of 14 would still give us 14. There are 2 and 7, and so we need to ask the question, does 2 divide evenly into 33? And the answer is no, because 33 is an odd number. Well, what about the 7? Does 7 divide 33 evenly? And again, the answer is no. And that's because 7 times 4 is 28, which is too small, and 7 times 5 is 35, which is too big. 28 and 35, neither of which are 33. And so we know that 7 does not evenly divide 33. That means that there are no factors of 14, which are also factors of 33. And that means that 14 over 33 really is in reduced form. Now, I'd like to try another example just to make sure we've got the idea down. So let's do the following. Let's calculate 5 over 6 times 14 over 3. Now, I see here a proper fraction, that's the 5 over 6, and an improper fraction, that's the 14 over the 3. 14 is larger than 3, and that's why that second fraction is improper. So here's a quick question we should ask. Should we rewrite that improper fraction as a mixed number, for example, before we do any multiplication? And the answer here is emphatically no. The problem as it is written is in perfect shape for us to complete the multiplication. There's no problem with having an improper fraction there. So let's just do the problem the way it's written. And again, as we did in the previous example, we simply multiply the numerators and multiply the denominators separately, and we rebuild our answer, if you will, from the new numerator and new denominator that we get from those two products. So 5 times 14 is 70. You might need to do that with a little long multiplication like we've seen in previous lessons, no problem. And 6 times 3 is 18. So my answer is 70 divided by 18, or 70 over 18. Now, same question as we will always be asking. Is my answer in lowest terms? And I know immediately that that answer is not in lowest terms. Can you see why? Well, notice that the 70 and the 18 are both even numbers. And that means that they can both be divided by 2 at the very least. So let's go ahead and divide out a 2 from both that numerator and denominator and see what we get from there. I know that 70 divided by 2 is 35, and that might need to take a little long division to find, but you can do that if you need. And 18 divided by 2 is 9. So the answer can also be written as 35 over 9. Now, is that in lowest terms? It might be, and it might not be. Well, let's focus on that denominator. The only divisors of 9 that I care about are 3 and 9. Of course, 1 is a divisor of 9, but I don't care about that because dividing a 1 out wouldn't do us any good. So, does the 3 that divides the 9 also divide 35? The answer is no. You could go through long division if you'd like, and you'd see that 3 does not divide 35 evenly. Okay? And if 3 doesn't divide 35 evenly, then the 9 can't divide 35 evenly either. So in fact, 35 over 9 is the answer in lowest terms. Now, before I leave this example, let me mention one other way we might write that final answer. Some folks don't like leaving their answers as improper fractions. Do you see that 35 over 9 is an improper fraction because the 35 is larger than the 9? In that case, we should rewrite the answer as a mixed number. In fact, that's the only other choice we have if we don't want to write it as an improper fraction. Do you remember how we would write such a fraction as a mixed number? Well, we first ask how many times the 9 will go into the 35. In that case, it's going to be 3 times because 9 times 3 is 27, but 9 times 4 is 36, which is too big. What is the remainder when we take those 3 9s out of 35? Well, it's 8 because 35 minus 27 is 8. The 27 is 3 times 9. So we now know how to write 35 over 9 as a mixed number. It's equal to the whole number 3 and 8/9 as the extra fraction at the end. So the final answer can be written as 35 over 9 or as 3 and 8/9. Now, as we prepare to look at the next example, let me make a quick comment. Probably the most time-consuming part of these multiplication problems is the work that has to be done to make sure that the answers are in lowest terms. Now, let me walk through a couple of examples to show you how we can try to minimize the work that we have to do from the beginning of the problem in order to get our answer into lowest terms. Let's do the following together. Calculate 10 over 12 times 20 over 25. Now, I can imagine some of you looking at this problem and saying, no way, I do not want to mess with this because the numbers are going to get too big when I do the multiplication, and the problem is going to be really unenjoyable. Well, to be honest, I can see where you're coming from. I wouldn't necessarily want to do all that work either, but I'd like to work through this problem in the way we've worked on the other examples. And then I want to show you some other techniques, some new techniques that you and I can employ to make our work much easier. So hopefully I'll convince you that these new ideas will help you in doing these problems quickly. So to do the problem the way we did before, we're simply going to multiply the numerators and multiply the denominators and make a new fraction out of those two numbers. When I multiply the numerators, I'm going to have 10 times 20, which is 200. And when I multiply the denominators, I'm going to have 12 times 25, which equals 300. Now, you might want to do those multiplication problems, especially that second one, using the multiplication method that we talked about in a previous lesson. That would be a nice way to practice that technique if you'd like to go ahead and do that. But for now, let me just tell you that the numerators multiplied together give me 200, and when I multiply those denominators together, I get 300. So my answer is 200 over 300. Now I hope you see that that is nowhere near in lowest terms. In fact, 200 and 300 can both be divided by 100. And if I divide out the 100 from the 200 and I divide the 100 out from the 300, I'm just left with 2/3. And that really is my final answer. That's wonderful. But I have to be honest, I rigged the numbers in this example just a bit so that the reduction to lowest terms could be easily recognized and would go quickly for us. Did you notice how everything was a multiple of 100? Well, the reduction might not always be that easy, especially if the common factor isn't something obvious like 100. So we know that our answer is supposed to be 2/3, but I really don't want to have to do all that work to multiply up to get 200 and 300 if I can avoid it. So let's go back to the problem from the beginning and let's see if there's a way to whittle it down, if you will, so that we never really have to multiply big numbers together. Remember that the original problem was 10 over 12 times 20 over 25. Now let's think about something else we could do in order to make the problem work more quickly, if you will, or make the numbers stay small. Notice first of all that neither of the fractions in the original problem was in lowest terms. Before we ever do multiplication in a problem like this, we really are allowed to get those two original fractions into lowest terms. In fact, I would do that every time. So I would encourage us to start this problem by actually reducing the 10 over 12 and the 20 over 25. Well, the 10 over 12 is the same as 5 over 6. And the 20 over 25 can be reduced to 4 over 5. So the original problem can be rewritten as 5 over 6 times 4 over 5. And notice that one little thing of just reducing the original fractions has now made all of the numbers in the problem much smaller. And that's a great thing. But there's something else that we're allowed to do before we ever start the multiplying of the numerators and the denominators. We're actually allowed to cancel numbers from one of the fraction's numerators with another fraction's denominator. It's almost like reducing a fraction, but now we're sort of borrowing from one another's fractions. Hey, I'll use your numerator and this denominator, and so on. So, for example, those 5s that are now in the problem, the 5 in the numerator of the first fraction and the 5 in the denominator of the second fraction can cancel one another. And that leaves me a 1 in the numerator of the first fraction and a 1 in the denominator of the second fraction. The problem has now been whittled down to 1 over 6 times 4 over 1. Now, let's stop and make a couple comments. First of all, what I just described using some numerator and denominator only works with multiplications and divisions. I can't do that with addition and subtraction. But with multiplication problems like we're doing in this lesson, I'm allowed to borrow, so to speak, or cancel from a numerator and a denominator. So that's one thing to say. The next thing is, notice that we see that the 4 and the 6 also have a 2 in common with them. In fact, I'm allowed to cancel out a 2 from the 4 and a 2 from the 6. And when I do that, it leaves the original problem in the form 1 over 3 times 2 over 1. Notice that with all this work that we've done, we never multiplied anything. All I've been doing is whittling down or canceling out some common terms. And now, I really can't do anything more with any canceling. Now I can do the multiplication. It's almost like I do it at the very end, and it's almost trivial, because 1 times 2 is 2, and 3 times 1 is 3, and so my final answer is just 2 over 3. Of course, we already knew that was the answer, because I showed you how to do it before when we multiplied up and had 200 over 300. But here I see the same answer showing up, but the numbers never got big. I just kept whittling down the problem in a manageable way, almost an easy way by the end of it all, and so that the multiplication never got very big. Now, before we go to the next example, let me say this. These cancellation ideas that I just shared can only be done with multiplication and division. I said this a moment ago, but it's very important to emphasize. You cannot do this cancellation of numerators and denominators from different fractions the way we just did if you're working with an addition problem or a subtraction problem. So don't fall into the trap of trying to do these kinds of cancellations between the numerator of one fraction and the denominator of another fraction if you're adding or subtracting. Now, let's go ahead and look at another problem. I'd like to suggest that you work on this one first, and then we'll come back together to see how you did. Let's multiply 12 over 15 times 35 over 22. Okay, again, as before, I do not want to multiply 12 times 35 and 15 times 22 if I don't have to. I can do it, I know how to do it, but I don't necessarily want to do it that way. I'm allowed to do the problem in another way, which is to do some of this reducing and canceling like we did in the previous example. So the first thing I see is that there's a 12 and a 22, which are both even. So I'm allowed to cancel a 2 from each of those. And that's going to change my problem, if you will, reduce my problem to 6 over 15 times 35 over 11. So far, so good. The numbers are getting smaller. Next, I see that there's a 5 that can be canceled from the 15 and from the 35. I know that 35 over 5 is 7, and 15 over 5 is 3. So I can rewrite my problem again as 6 over 3 times 7 over 11. Notice that we've really cut down the workload now. The numbers continue to get smaller and smaller, but the final answer is still going to be exactly right. It's going to be the same answer as we would have had from the original way to write the problem. Now, before I multiply everything out, I see one more thing that I can do. Do you see it? Notice that the 6 and the 3 that are both in that one fraction have a common factor of 3 in them. So I can rewrite 6 over 3 as 2 over 1. That's after I divide the 3 out from the 6 and I divide the 3 out from the 3. And that makes my original problem 2 over 1 times 7 over 11. Now, to be honest, I don't see any more canceling that we can do. If I did, I would suggest we continue doing it, but there's no more canceling that can be done. And so now we have to do the multiplying of the numerators and the multiplying of the denominators. But notice by doing all that canceling, the multiplying job now is pretty easy, to be honest. Since 2 times 7 is 14 and 1 times 11 is just 11, I know that my answer must be 14 over 11. And notice that that fraction, that answer, 14 over 11, is already in reduced terms, and that's because the only factor of 11 to consider is 11, and 11 is not a divisor of 14. So my final answer really is 14 over 11. If I'm okay with writing it as an improper fraction, if I want to write it as a mixed number instead, then my final answer needs to be 1 and 3 over 11. Now, I'd really like to move to a couple other types of problems that can arise when you work with multiplication involving fractions. The first kind of problem is this. What if I wanted to multiply a fraction and a whole number? Is that a tough thing? It turns out it's not a problem at all. Let's do an example. Let's calculate 2 over 7 times the whole number 5. Now, for some of you, this might be a real roadblock. I mean, what in the world are we going to do? Mainly because that 5 is not a fraction. I mean, to multiply fractions, I had to have a numerator in each to multiply together and a denominator in each to multiply together. What do I do now? Well, it's not a problem. Let's just rewrite 5 in an equivalent way as a fraction. Can you think of a way to write 5 so that it has a numerator and a denominator? The answer is just to write it as 5 over 1. If you think about it, how many times does 1 go into 5? It goes in 5 times. So the number 5 really is the same as the fraction 5 over 1. And that means my original problem can be rewritten as 2 over 7 times 5 over 1. Well, that looks like one of the problems we just finished a few minutes ago. And in fact, there aren't even any things to cancel or to whittle down. I just need to multiply the numerators and multiply the denominators, and I'll be done. 2 times 5 is 10. 7 times 1 is 7. And so my answer is simply 10 over 7, or 1 3/7 if you want to write it as a mixed number. And that's it. No problem at all. Just rewrite the 5 as 5 over 1. Now, let's try another one. Let me suggest you try this, the same idea. Let's multiply the whole number 6 times the fraction 8 over 12. Okay, let's look again at the problem and let's see what we have. We have a whole number, the 6, being multiplied by a fraction. Okay, what did we do in the previous example? We rewrote the whole number as a fraction. So in this case, I want to write the 6 as 6 over 1. And that means my original problem now looks like 6 over 1 times 8 over 12. Now, Just as with the other examples we've done, let's do some of this canceling, or what I like to call whittling, in order to make the numbers as small as possible before we do the multiplication. Notice that the 6 and the 12 can share in some of this cancellation. I know that 6 divides 6 exactly 1 time, and I know that 6 divides 12 exactly 2 times. So I can rewrite my problem as 1 over 1 times 8 over 2. No problem there. Now notice that the 8 and the 2 are both even, so they can both have a 2 divided out of them. 8 over 2 is actually 4, and 2 over 2 is 1. So my problem can be rewritten again as 1 over 1 times 4 over 1. And again, I can't emphasize enough, I haven't done any multiplication yet. I've just been rewriting the problem in smaller and smaller forms by doing cancellation. Now the multiplication can be done, but my word, it's extremely straightforward because I have 1 times 4, which is 4, and 1 times 1, which is 1. Be careful not to call that 2. Some people like to do that. So I have 4 on top, and I have 1 on the bottom, which means my answer is just 4 over 1. But remember, that's just a disguised form of the whole number 4. Anytime you have a whole number divided by 1, it's just that whole number. So what did we just find? Well, we just showed that the product, the multiplication of a whole number and a fraction can actually sometimes turn out to be another whole number. In fact, the product of 2 different fractions can also turn out to be a whole number at times, depending on the fractions you start with. Pretty cool. So fractions don't always give you fractions at the end. Sometimes they actually give you whole numbers, which of course you can think of as a fraction with a 1 in the denominator. Now, let's turn a corner and see what happens if we want to multiply a fraction with a mixed number. That's an even different kind of problem. So let's look at this one. Let's calculate 2 3/4 times 10 over 33. Now, some of you might be saying, oh my word, I've already seen enough of these different kinds of problems in this lesson. What am I going to do here with a mixed number? It turns out it's actually pretty straightforward to do as long as you do the problem in the right steps. The first step here, whenever you have a mixed number and you want to multiply with it, is to change that mixed number to an improper fraction. Remember that it's the same as writing something like 2 as 8 over 4, if you will, or something along those lines. So I'm going to take that mixed number that I had, and I'm going to rewrite it as an improper fraction. In this case, that 2 is 8 over 4. And so what I'm really looking at is 8 over 4 plus 3 over 4. That's what the 2 3/4 means. And 8 over 4 plus 3 over 4 is 11 over 4. We did that in the previous lesson when we added fractions. So my original problem is just the same as 11 over 4 times 10 over 33. Well, I know how to do that kind of problem. You and I have been doing examples like that throughout this lesson for the last several minutes. So let's now attack 11 over 4 times 10 over 33. If we can think about some nice cancellations up front, the multiplying won't be so bad. So let's first think about doing some reduction of the fractions, and then let's multiply to get our final answer. Notice that both the 10 and the 4 are even. So let's divide both of those by a 2, and when I do that, I'm going to end up with 11 over 2 times 5 over 33. Notice also, and you may not have noticed this too quickly, but notice that the 33 is divisible by 11. And of course, the 11 that's up in that numerator of the first fraction is also divisible by 11. So I can factor out an 11 from the 11 in the numerator and the 33 in the denominator, and that's going to leave me with the product 1/2, or 1 over 2, times 5 over 3. And again, we started with 2 fractions that had relatively messy looking numbers in them. They weren't huge, but they weren't the friendliest looking. And now we're down to 1 over 2 times 5 over 3. Now we can do the multiplication, multiplying the numerators together, multiplying those denominators together. And when I do, I'm going to have 1 times 5, which is 5, and 2 times 3, which is 6. And our final answer then is 5 over 6. That's already in reduced form, and that's my final answer. So notice something before we move past this. We started with a mixed number times another fraction, and we ended up with a very friendly looking, pretty small fraction at the very end. Very nice problem. Now, let's transition and look at another example. Here I actually want to multiply two mixed numbers together. Okay? Let's calculate 4 1/6 times 8 2/5. Now look, this is about as hard as it's going to get. Two mixed numbers multiplied together. It probably feels a bit daunting, but let me suggest you try it yourself first, and then we'll come back together to see how you did. Okay, remember that as with the previous example, when I had a mixed number in my multiplication problem, I went ahead and rewrote it as an improper fraction before I did anything else. That's exactly the first step I want to do in this example as well. Let's start with the 4 1/6. A quick way to rewrite this as an improper fraction is to multiply the 4 times the 6 to get 24, and then to add the 1 that's in the numerator to get 24 plus 1 equals 25. That 25 tells you that 4 1/6 is the same as 25 over 6. So that mixed number is now rewritten as an improper fraction. Excellent. Now let's look at the other mixed number, 8 2/5. That can also be rewritten as an improper fraction by multiplying the 8 by 5 to get 40. 8 times 5 is 40. And then add the 2 that's in the numerator. 40 plus 2 equals 42. That 42 tells you that the mixed number 8 2/5 is the same as 42 over 5. So my original problem, which started out with two mixed numbers, is the same as 25 over 6 times 42 over 5. Now, I'll admit that that took some work to rewrite that problem. That's true. But now that it's rewritten, it just looks like all the other problems that we've been doing in this lesson. And we know how to attack those now. So let's go through our reductions, our cancellations, our whittling, as I like to call it, and then let's multiply whatever's left after we've done as much cancellation as we can see. First, the 25 and the 5 can be reduced because both are divisible by 5. And that will make my problem 5 over 6 times 42 over 1. Remember, 5 goes into 5 exactly one time, and that's why I put that 1 in the second denominator. Next, 42 is divisible by 6 exactly 7 times, and of course the 6 is divisible by 6 exactly one time, so I can rewrite my problem again with a little more reduction as 5 over 1 times 7 over 1. Well, that's as simple as we can make the problem before we actually do the multiplication. So let's perform those multiplications now. 5 times 7, I know from my multiplication facts, is 35. 1 times 1 is 1. Don't forget, 1 times 1 is 1. And so my answer is 35 over 1, which is just a disguised version of the whole number, 35. So if you got that answer, you're doing a wonderful job with the multiplication with mixed numbers. Now, before I leave this problem, notice what just happened. We actually multiplied two mixed numbers together. They were pretty messy looking mixed numbers, in fact, and we got a whole number back as the answer. It's a bit unexpected, but it can happen. Notice also that our answer seems to be in about the right ballpark if we critically think about our answer just for a moment. We started with a number that was just bigger than 4 and another number which was just bigger than 8. So we should have expected that our answer when we multiplied would have been a little bit bigger than 32, and we got 35. That's a good sign. If we had arrived at an answer like 10 or 100 or 1,000, we would have known that our answer was too small or too large. This answer of 35 looks just right. Well, in the last few lessons, we've talked about adding, subtracting, and multiplying fractions. You can probably guess what we're going to do in the next lesson. That's right, we're going to talk about division of one fraction by another fraction. It turns out that division of fractions is very closely related to multiplication of fractions. So make sure you have this multiplication of fractions work nailed down firmly before we move to our next lesson.